Welcome back. This is the 5th video in the Test First Development series. And in this one, we are finally going to write some tests. Yay! This video might be a little bit longer than some of the others because we really do have quite a bit to cover. So the first thing we need to do is we need to set up some references here. So I'm going to right click on my coffee shop tests and I'm going to say add project reference. And I want to make sure that we can use coffee shop lib from within our coffee shop tests. And then we're going to need to set up the using clause here where we say we're using NUnit.framework and also that we are using coffee shop lib. And I'm going to rename this class. So let's right click, rename, and I'm going to call this coffee shop tests. Now, there is a method to my madness here. What I tend to do is for every class in the library, I have a corresponding class in the test library called class name tests. So if I had lots of classes here, you would see lots of test units all named accordingly. Okay, now we get to write some code. So the first thing we have to do is we have to put an attribute on this class, marking it as a test fixture. So this attribute, this is an NUnit attribute, and it tells the NUnit framework that this class is going to contain some tests. And then we get to write our tests, and each test is marked with a test attribute. So we're going to write what I'm calling the happy path tests. These are testing just the basic functionality, no error conditions, no edge cases, just the core app functionality. So let's do public void place order. That's a test we could write. And we're going to create an order, place it, check the return value. And then another test we could write would be public void cancel order. So we can create an order, cancel it, and we can check the status. And another test we could write would be public void get order status. That was one of our methods. So we can place an order, check the status. It should be pending. And one other happy path test situation is public void wait for order completion. So that will look something like place an order, wait a minute, it should be completed. So those are the main happy paths through our code. This technique that I'm doing here is called comment first development, and I strongly recommend you try it out. You just write the comments about what the function should do, and then leaving the comments in place, you go back and write the function. So now let's write our test. So what are we going to do? First thing we do is we're going to create a coffee order. And for this coffee order, we can say drink name equals latte and quantity equals 1. So we're ordering a single latte. And then we will say coffee order return or result equals coffee shop dot place order, and we'll put in our order. So sometimes people like to name this input and output for these kinds of functions. I think that's a nice way to do it. And now we write our actual NUnit test code. And this is all done using NUnit assertions. So an assertion just is a proposition that will evaluate to true or false. And if it's not true, then the test will fail. So we can say assert is not null output. So that would be a problem. If the output came back null, that would be a fail. And we can also say assert dot is equal input dot drink name and output dot drink name. Those should be the same. And another one, I think it's R equal. There we go. Another valid assertion based on kind of just our understanding of the app is that the output quantity and input quantity should match. So what are some of the other business rules we wrote down? We can go back and look at coffee shop. Okay, so the order number better be greater than 0, and the status should be pending, and the order date should be today. So we can test all of those. Assert dot is true. Output dot order number is greater than 0. And another rule would be assert dot are equal order status dot pending output dot status. Now I want to pause there. You may wonder why I chose that order. In some ways, maybe you would think, well, this is the thing we're checking and this is the value we want. The reason I've done it this way is that when these kinds of tests fail in NUnit, what it tells you is this is what I expected and this is what I actually got. So putting the sort of known expected value first makes the error messages a little bit easier to understand. So another assertion we could do here is assert R equal datetime dot today and output dot order date dot the date of the order date. So those should be the same. And I think that covers our business rules for placing an order. So there is a nice happy path test. How about canceling an order? So to do that, we can copy some of this code. Now, in a later video, I'm going to talk a lot about how you write good test code. And I'll come back to this, but one of the things you'll notice is that certain patterns of coding that would be considered poor form in production code actually work really well and are totally acceptable in test code. And having code duplication is one of those. In production code, if you see code duplication, you often want to refactor that and just create some common code that everything can share. That's a really good practice. But I like to write tests that are fully self-contained and don't have a lot of external dependencies. So I'm actually just going to copy that down here, and it doesn't bother me. It's test code, so the style is a little bit different and the purpose is different. So now what we can do is we can try to cancel this order. So what we're going to say is coffee shop dot cancel order, and we're supposed to pass in the integer of the output. So that'll be output.order number. And then we can say order status equals coffee shop dot get order status. And we want to use our order number. And now our assertion, assert dot are equal order status dot canceled and status. So there is a very simple test. Again, we do have some code duplication, but it doesn't bother me. I really like it that this little test works completely on its own and has no external dependencies. So now we have a function called getOrderStatus. And once again, we can actually copy a lot of this code, save us some typing. And in this case, it's really the same test, but without canceling it. and that should be pending. Now you're saying, didn't we already test this? Doesn't this test kind of cover the same case as this test? And the answer is yes. We actually have some duplication here. And you might convince yourself, oh, well, I don't really need to write this separate test because it's covered by that one. But again, what I would say is a little code coverage duplication where two tests kind of exercise the same code, there's no penalty to that. There's no harm. And this matches up with our business rules and our functions. So we really are guaranteeing that we're not missing some test. Now, the last one will be wait for completion. So let's place an order. And then we can do system.threading.thread.sleep. And why don't we just sleep for 1.5 seconds? Make sure we go beyond a second. And then we'll pull our order status, and this one should be completed. All right, so we have now written all of our tests. This is our happy path test. So the last thing that we need to do is run them. We're actually going to execute these tests. So the way you do that is you click Test Explorer, and it brings up this kind of cool Test Explorer window, which you can dock where you want and use. And because we've installed all those units, the Test Explorer actually finds not only your test fixture, but all of the tests that are part of the test fixture. So the first thing we can do is build our project. If there have been any changes when you run the tests, it automatically builds. And now I'm going to right click on our coffee shop tests, and I'm going to choose run. We're going to run our tests. Let's see what happens. Fail, 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 fail. Well, that's exactly what we expected. And we can see they're failing because the actual tests are throwing a not implemented exception. And if you look at this, you can actually see exactly where it failed. So if we go to, it failed in the place order test, and we can go right here on line 25. It should highlight the code for us, and you can see where that is. And we can also see where the cancel order is failing. Now, one last thing before I end this long video. You'll notice that I wrote these tests in kind of the logical order, like place order, etc. It's running them in alphabetical order. And this is one of the irritating things about NUnit. It just runs your tests in alphabetical order. So if you care and you want to make your tests run in a certain order, you do have to do things like, if I want place order to be first, I probably have to name it something like A_place order, and then it'll go first. And then I could just go rerun that one test if I wanted. And it ought to fail exactly like we thought. I don't particularly want to name them that way. I'm going to put it back. So there you go. Just to review, we set up a test fixture. We wrote some happy path tests. We filled them in with the actual assertions that eventually will pass once we get our code correct. And we did an initial run of the tests to verify that they were failing. So this is success. All those failures is success. So those are your first tests. Congratulations. I'll pause it here and give you a chance to catch up and write your own.